Hi my dear students, welcome back to our amazing YouTube channel of Brilliant Katha. This is the 6th video lecture in our JEE Mantra series, and in this lecture we will be revising the complete two-dimensional geometry. Okay, so in this 2D geometry, first we start with straight lines, pair of straight lines, circle, parabola, ellipse, and we end up with hyperbola. So first we'll start with straight lines, friends. In straight lines, we'll go with the basic formulae from geometry part, two-dimensional geometry part. Let's say section formula, distance formula. So first we'll go with the distance formula. In distance formula, if a of x1 comma y1 and b of x2 comma y2 are any two points in the Cartesian plane, then the distance between AB is given as square root of x2 minus x1 whole square plus y2 minus y1 whole square. This formula is distance formula. Next, distance from origin to a given point OA is square root of x1 square plus y1 square. OB is equals to square root of x2 square plus y2 square. Next, section formula means if P is a point which lies inside the join of line segment AB and P divides AB in the ratio m:n, then AP by PB is equals to m/n, and this division is internal division. So if P divides AB in the ratio m:n internally, then coordinates of P will be mx2 plus nx1 divided by m plus n, comma my2 plus ny1 divided by m plus n. Suppose if there is another point Q, which is dividing the join of AB, suppose in the same ratio m:n, but externally, friends, Q is dividing AB in the ratio m:n externally. So then that becomes AQ by QB is equals to, if the division is external division, then we take ratio is negative. So in that case, coordinates of Q will be mx2 minus nx1 divided by m minus n, comma my2 minus ny1 divided by m minus n. And friends, if you observe one thing here, for the line segment AB, P and Q are the two points which are dividing AB in the same ratio, but one internally, the other externally. So these 2 points are called as harmonic conjugates. Harmonic conjugates of capital A comma B. P comma Q are said to be harmonic conjugates of A comma B if P and Q divides in the same ratio, but one internally, the other will be externally. Next, we'll start with straight lines. In straight lines, the basic terminology that we have is inclination, friends. Inclination means the angle made by a line with the positive direction of x-axis. That's it. The angle made by any line with the positive direction of x-axis. So let's take a line. The angle made by any line with the positive direction of x-axis. Positive direction means anti-clockwise direction. So for this line L equals to 0, theta is said to be inclination. Now the range of theta will always be from closed 0 to open pi. That means 0 less than or equals to theta less than pi. Now if inclination is theta, then slope means tangent of inclination. So tan theta is said to be the slope of the given line. Slope of the given line, and generally we denote slope as letter m, small m. So m is equals to tan theta, and you know the range of tan theta is always from minus infinity to plus infinity. So m can be positive, m can be negative, m can be 0, m anything. M belongs to set of real numbers. Clear? So this is what we say slope of the given line. Now suppose if this line is passing through 2 points x1 comma y1 and x2 comma y2, then slope of this line, if 2 points are given, m is equals to y2 minus y1 divided by x2 minus x1. y2 minus y1 divided by x2 minus x1. So that is why we say slope of x-axis. If we consider any 2 points on lying x-axis, for them y coordinates will be 0. So 0 minus 0 divided by x2 minus x1. That means 0 by something which is 0. So m equals to 0 for all horizontal lines. So for all horizontal lines, slope is 0, and for all vertical lines, slope is not defined. Next, collinearity. Collinearity, till now we have seen many methods like distance formula and all. Now see this, friends. Suppose capital A, capital B, capital C are collinear. Then generally by using distance formula, AC is equals to AB plus BC. The higher of them should be equals to the sum of the remaining two. By using straight lines, if slope of AB is equals to slope of BC, then also they are said to be straight lines. So even if slope of 2 points is equals to slope of another 2, then we say that the given 3 points are collinear. Next, different forms of equations of line. So first we'll go with the slope point form or point slope form. In slope point form, you will be given with slope m and a point x1 comma y1. Then they will be asking us to find the equation of straight line. So equation of straight line with slope m and passing through a point x1 comma y1 is y minus y1 is equals to m of x minus x1. Next, 2 points form. If they give you 2 points, the equation of line which is passing through 2 points x1 comma y1 and x2 comma y2 is y minus y1 is equals to, friends, when you know 2 points, if the line is passing through 2 points, then you can get slope. What is slope? y2 minus y1 divided by x2 minus x1. Everything we take from this only. Every equation will take this as the standard form and then we'll get. So 2 points form. Next, slope intercept form. In slope intercept form, there are two: slope and y-intercept, slope and x-intercept. Slope given and x-intercept given. Suppose if slope and x-intercept are given, let m denotes the slope of the given line and c denotes y-intercept. Okay. Now the equation of the line is y is equals to mx plus c, and if m denotes slope and c denotes x-intercept, then the equation of the given line is y is equals to m of x minus c. Don't get confused, friends. If c is y-intercept, then the equation of the line is y is equals to mx plus c. This is the equation where we use very good number of times. Next, intercepts form of a line. If a line has intercepts x-intercept a and y-intercept b, then the equation of the line is x by a plus y by b is equals to 1. So generally x by a plus y by b equals to 1 denotes the equation which is passing through the 2 points. X-intercept a means it cuts x-axis at a point a comma 0. If y-intercept is b, it cuts y-axis at a point 0 comma b. So this is the equation of the straight line which is passing through the 2 points a comma 0 and 0 comma b. Now we have very good question like, what is the area of the triangle formed by the line x by a plus y by b equals to 1 and coordinate axis? See, friends, if this a comma 0 or a is the x-intercept, that means this length will be a, b is y-intercept, this length will be b. Now this is a right angle triangle, so area of triangle OAB is equals to half into base into 8, that is half mod AB. Area of the triangle formed by the line x by a plus y by b equals to 1 and coordinate axis is half into modulus of AB. Okay. Next, angle between two lines. The angle between two lines having slopes m1 and m2. If there are two lines, one line is having slope m1 and the other is having m2, and if theta is the angle between them, if theta is the angle between the lines having slopes m1 and m2 is tan theta is equals to modulus of m1 minus m2 divided by 1 plus m1 m2. If theta is acute, friends. Generally, angle between two lines means one. If this angle is acute, then other will be obtuse. So if this is 30, this will be 150. So you can say either 30 degree be the angle or 150 degree be the angle. Suppose if I say theta is acute, then tan theta should be positive, no? So tan theta is equals to mod m1 minus m2 divided by 1 plus m1 m2. From this only we can say, see friends, if the two lines are parallel, then theta will be equals to 0. So 0 is equals to this. That means numerator m1 is equals to m2 if two lines are parallel. So if the lines are parallel, then their slopes will be equal. Next, if lines are perpendicular, that means angle between them is theta 90 degree. So theta equals to 90. Tan 90 is not defined. What do you mean by not defined? Denominator 0. Denominator should be 0. So if two lines are perpendicular, then m1 into m2 is equals to minus 1 if two lines are perpendicular. Next, normal form of a line. This is one unique form, friends. This is one unique form of a line. In this, generally, do understand. Suppose there is one line. For this line, x-axis, y-axis, origin. They have given only two things. One is the perpendicular drawn from origin to the given line. Let's say this is OM. The length of the perpendicular they give you. So let's say this is some P. And the angle made by perpendicular with x-axis, with positive x-axis. Okay, angle made by perpendicular with positive x-axis in anti-clockwise direction. So here what is P, boss? P is length of the perpendicular. And what is alpha? Angle made by perpendicular. Angle made by perpendicular with positive x-axis. With positive x-axis. So if P is the length of the perpendicular drawn from origin to the line and alpha is the angle made by perpendicular with positive x-axis, then the equation of the required straight line, that means this straight line is, equation of this required straight line is x cos alpha plus y sin alpha is equals to P. Right hand side it should be P ma. This P should always be positive because P is, what does P denotes? P is the length of the perpendicular. Distance will always be positive, no? So x cos alpha plus y sin alpha is equals to P, and the value of alpha can vary from close to 0 to 2 pi. Close to 0 to 2 pi. Next, parametric form of a line. Parametric form of a line means if a line makes an angle theta, or if a line has inclination theta, inclination theta, then x minus x1 by cos theta is equals to y minus y1 by sin theta is equals to r is the parametric form. So parametric form is very important for finding the point which is at a distance of r units from the given point on the line. So consider there is one line, friends. Now this line is making an angle theta. Now we have a point x1 comma y1. Okay. Now we need to find a point which is at a distance of r units above x1 comma y1. If I say r units from x1 comma y1 on the same line, there will be 2 points. So one will be above it and one will be below it. Okay. So this distance is r now. This distance is r. So now the coordinates of this point will be x1 plus or minus r cos theta, comma y1 plus or minus r sin theta. We take plus sign if the point lies above it. If we take plus sign if the point lies above x1 comma y1, and we take minus sign to get the point which lies below x1 comma y1. So this is how parametric point is important. To get a point on the same line which is at a distance of some r units from a fixed point x1 comma y1, we use parametric form. Foot of the perpendicular, distance, image. Let's say, friends, foot of the perpendicular means we have a point p of x1 comma y1, let's say, and we have a line ax plus by plus c is equals to 0. If a perpendicular is drawn from point P to the given line, if a perpendicular is drawn from point P to the given line, let's say this intersects the line at M, then this M is called as foot of the perpendicular. This M is called as foot of the perpendicular. And now, length of the line segment PM, length of the line segment is called as distance from point P to the given line. So PM is equals to modulus of, we substitute point in this line, mod of AX1 plus BY1 plus C divided by under root A square plus B square, perpendicular distance from a point to given line. Next, coordinates of foot of the perpendicular. Let's say H comma K. We use this formula, friends. So to get coordinates of the foot of the perpendicular, we use the formula h minus x1 by a is equals to k minus y1 by b is equals to minus of ax1 plus by1 plus c divided by a square plus b square. Don't get confused. It is not square root of a square plus b square. It is only a square plus b square. Okay. Next, we have another point called image. What do we mean by image? Image means, friends, if we extend this PM to some point R, such that PM is equals to MR, then R is said to be the image of P with respect to the line AX plus BY plus C is equals to 0, or R is said to be image of x1 comma y1 in the line AX plus BY plus C is equals to 0. Now let's say alpha comma beta be the coordinates of that image. So how do we get that image? Same formula, friends. Alpha minus x1 by a is equals to beta minus y1 by b is equals to, in place of minus 1 we put minus 2 of ax1 plus by1 plus c divided by a square plus b square. Clear? Next, special points in a triangle. Coming to special points in a triangle, if there is a triangle with vertices x1 comma y1, x2 comma y2, x3 comma y3, ABC is a triangle with vertices x1 y1, x2 y2, x3 y3. Now number one, centroid. What is centroid? Centroid is the point of intersection of medians. Centroid is the point of intersection of medians, and the coordinates of centroid, if vertices are known, that is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. Generally we denote centroid with G, and you know, friends, centroid divides the median in the ratio 2:1. Centroid divides the median in the ratio 2:1. Let's say AD is the median. Then if G is the centroid, G divides AD in the ratio 2:1. That is AG by GD is equals to 2 by 1. Okay. And not only this, centroid divides the whole triangle into 3 equal parts. That is area of triangle AGB is equals to area of triangle BGC is equals to area of triangle AGC. All these are equals to 1/3 of the area of triangle ABC. 1/3 of the area of the triangle ABC. Next, circumcenter, or we say circumcenter. Circumcenter, generally we denote circumcenter with capital S, and circumcenter is the point of intersection of perpendicular bisectors of the sides. Perpendicular bisectors of the sides of the triangle. So now there exists one unique circle passing through the vertices of the triangle, that is circumcircle, and the center of that circle is circumcenter. Let's say if this is S, circumcenter will always be equidistant from all the three vertices, that is SA is equals to SB is equals to SC. Next we have incenter. Incenter, the point of intersection of angular bisectors. Point of intersection of angular bisectors. Angular bisectors is incenter, and if I denotes incenter, let's say this is capital I. If I denotes incenter, so AE is the angular bisector. AE will be the angular bisector. Now this AE divides BC in the ratio. AE divides BC in the ratio, that is BE by EC is equals to BE by EC is equals to AB plus AC divided by BC. AB plus AC divided by BC, and I divides AE in the ratio, that is AI by IA is equals to AB by AC. These two are the two important ratios that we have. Okay, next we have orthocenter. Orthocenter is point of intersection of altitudes. Point of intersection of altitudes. In right angle triangle, the orthocenter is the right angled vertex itself. Okay, this is the point to be noted. And circumcenter, in right angle triangle, the circumcenter is midpoint of the hypotenuse. In right angle triangle, the circumcenter is midpoint of the hypotenuse. Okay, next, locus of a point. Locus of a point is so simple, friends. Locus means the path traced by a point subject to the given conditions. Subject to the given conditions. So in finding the locus of any point, what to do? First, consider the point as P of H comma K. Whatever the point that they are asking us to find locus, take that point as P of H comma K. Okay. Next, write all possible geometrical conditions. And establish a relation between in H and K, excluding the parameters. There shouldn't be any parameter, excluding the parameters. Now in the final, after simplifying it, final, replace X in place of H and Y in place of K to get the final locus. To get the locus of point P. So this is how we find the locus of a point. Locus means the path traced by a point subject to the given conditions. So how to get the locus? Consider the given point as P of H comma K, write all the possible geometrical conditions and establish a relation in H and K excluding the parameters. Excluding the parameters. In the final, after simplification, replace X in place of H and replace Y in place of K to get the locus of the variable point. Angular bisectors. Let's say, friends, there are two lines. Equation of one line is a1x plus b1y plus c1 is equals to 0, and another line is a2x plus b2y plus c2 is equals to 0. Now for these two lines there will be two bisectors. One will be acute angle bisector and there will be obtuse angle bisector, and these two bisectors will always be perpendicular. Okay, this is acute angle bisector and this is obtuse angle bisector. So equations of these two bisectors are a1x plus b1y plus c1 divided by square root of a1 square plus b1 square is equals to plus or minus a2x plus b2y plus c2 divided by square root of a2 square plus b2 square. Now friends, as we have plus or minus, that means we'll take plus. If you take plus, we'll get one bisector, and if we take minus, we'll get another bisector. These two are acute and obtuse angle bisector. But what is acute, what is obtuse? That is given by the sine of a1 a2 plus b1 b2. Find the sine of this a1 a2 plus b1 b2. This is the sine of obtuse angle bisector. So friends, if they ask find the obtuse angle bisector, now we'll find the sine of a1 a2 plus b1 b2. If this is positive, that means if we take plus sign, we'll get obtuse angle bisector. And if this is negative, if we take minus, we'll get obtuse angle bisector. And if they're asking us to find acute angle bisector, we'll take the opposite sign of this. Here, this is regarding angular bisectors. Next, reflection property. Reflection property is similar to this angular bisectors. In this, the most important thing is, friends, suppose we have one bisector. We have one bisector. This is the bisector B1 is equals to 0. L1 equals to 0 and L2 is equals to 0 or any two lines. The only one thing is, friends, the image of the point, let's say P is any point on L1 is equals to 0. The image of point P in the line B1 is equals to 0 will always lie on L2. The image of P with respect to the bisector will be lying on L2 is equals to 0. So the image of any point on L1 is equals to 0 with respect to the bisector will always lie on the another line, that is L2 is equals to 0. This is the most important property of this is the most important reflection property that we have it in straight lines. Next, pair of lines. So we know every second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 won't represent always a karma. It won't represent a conic all the time. Okay. So ax square, this is the general second degree equation in x and y. Ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. We have a factor called delta. Delta is abc plus 2fgh minus af square minus bg square minus ch square. Clear? Delta is equals to abc plus 2fgh minus af square minus bg square minus ch square. If this delta is equals to 0, then this curve represents pair of straight lines. And if this delta is non-zero, then only it represents conic sections. That means it can be circle, it can be a parabola, it can be a ellipse, it can be hyperbola. So for all these conic sections, delta should always be non-zero. If delta is 0, then that equation represents a pair of straight lines. So for every second degree general equation in x and y, if delta is 0, then that represents a pair of straight lines. Okay. Next, homogenization. Homogenization means we have a curve. Let's say equation of curve is some ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0. Now homogenizing the given curve with respect to the line lx plus my is equals to 0. This is the line lx plus my plus n is equals to 0. Homogenizing means simple concept. What do you mean by homogenizing? See, this is a second degree equation in x and y. But is it homogeneous? See, degree of this term 2, 2, 2. But this term is 1, 1, 0. So that means this is not homogeneous. Okay, this is not homogeneous curve. So to make it homogeneous, here we need degree 2. Correct? Here we need degree 2. Here also we need degree 2. Here also we need degree 2. So we are going to homogenize this given curve with respect to the line. When you homogenize, what do you get? We will be getting a pair of straight lines, passing through origin and intersecting the given curve at these 2 points. If suppose A comma B are the 2 points of intersection of line and curve, then when you homogenize the given curve with respect to the line, then you will get pair of straight lines passing through origin, pair of 2 straight lines passing through origin and intersecting the given curve at A comma B. So the combined equation of OA and OB will be now AX square plus 2HXY plus BY square plus homogenizing means with the help of this line. See guys, LX plus MY plus n is equals to 0 is equals to minus n. So Lx plus my divided by minus n is equals to 1. Now 2gx can be multiplied with 1. We won't get any change. Plus 2fy is also can be multiplied with 1. Plus c into it can be multiplied with 1 square. No change, because anything into 1 is the same thing. Into 1 square will also be same thing. Now this one replace with Lx plus my divided by minus n. So when you replace it, what happens friends? Ax square plus 2hxy plus by square plus 2gx into 1 is Lx plus my divided by minus n plus 2fy into 1 means Lx plus my divided by minus n plus c into n 1 square is Lx plus my divided by minus n whole square is equals to 0. Now by doing this, what do you get? See, second degree degree 2, 2gx into Lx again degree 2, 2gx into my again degree 2. So each term of this equation will be of degree 2 ma. Clear? So such equation represents a pair of straight lines passing through origin. So homogenizing the given curve means you will be getting a pair of straight lines passing through origin and intersecting the curve at the same 2 points, capital A comma capital B. OA and combined equation of OA and OB we get. Next. So this is regarding straight lines and pair of straight lines. Now we'll go with circles friends. So a circle is the locus of a point which moves in the plane such that it is always at a fixed distance from a fixed point. So that fixed point is called as center of the circle and fixed distance is called as radius of the circle. Fixed point is distance, fixed distance is center, this fixed distance is radius of the circle. Let's say P is the variable point, always Cp is equals to R. Standard equations of the circle. First one is center radius form. So if you know center as h comma k and radius r, then the equation of the circle is x minus h whole square plus y minus k whole square is equals to r square. Next, general equation of the circle. As usual friends, this equation represents a circle if h is equals to 0 and the coefficient of x square is equals to coefficient of y square. So ax square plus 2hxy, ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equals to 0 represents a circle if number 1 delta should not be 0, correct? In delta should not be equals to 0 and h equals to 0 and the coefficient of x square should be equals to coefficient of y square. So these things happen, then only it will be a circle. Next. So now second degree equation, general form of a circle will always be of the form x square plus y square plus 2gx plus 2fy plus c equals to 0, and for that center is minus g comma minus f. Radius is square root of g square plus f square minus c. Equation of the circle with the ends of the diameter known. If these two are the ends of the diameter, then equation of the circle is x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. And one more thing, another way of asking will be, find the equation of the circle which is passing through 2 points and having least radius. So the circle which is passing through 2 points and having least radius means this should be the diameter. Okay, so this is what again diameter end form. When circle touches x-axis, see friends, if circle touches x-axis, the k itself will be the radius. So x minus h whole square plus y minus k whole square is equals to r. R is k equals to k square. Now if circle touches y-axis, h will be the radius. So x minus h whole square plus y minus k whole square is equals to h square. If circle touches both x-axis and y-axis, h is equals to k. So x minus h whole square plus y minus h whole square is equals to h square. Next, intercepts made by a circle on x-axis and y-axis. See guys, what do you mean by intercepts? Intercepts means if a circle touches x-axis at 2 points, let's say capital A comma capital B, then the length of this line segment is called as x-intercept. Okay, in the same way, if it intersects y-axis at 2 points, let's say some C comma D, now length of the line segment CD is said to be its y-intercept. So for a circle x square plus y square plus 2gx plus 2fy plus c is equals to 0, its x-intercept is twice root g square minus c and y-intercept is twice root f square minus c. Equation of the circle in parametric point. Parametric form of circle is, from now friends, for every curve starting from straight lines we have seen. What is the, in straight lines we have seen x minus x1 by r cos theta is equals to y minus y1 by r sin theta. That is x1 plus r minus r cos theta comma y1 plus r minus r sin theta is the parametric form of straight line. Now in the same way, parametric point of a circle is r cos theta comma r sin theta. For a circle x square plus y square is equals to r square, parametric point is r cos theta comma r sin theta. For every theta, this point will always be lying on the circle. So in place of x, if we put r cos theta, in place of y, if we put r sin theta, then the parametric point of the circle is r cos theta comma r sin theta. Next, position of a point with respect to the circle. Let's say there is one point P of x1 comma y1. If the point P lies inside the triangle, then S11 less than 0. Lies inside S11 less than 0. Lies on the circle, S11 equals to 0. Lies outside, S11 greater than 0. So the position of point P, that means what is S11? S11 means substituting the point in the given equation. I have already given standard notations friends. S1, S11, S1 is also called as T. Clear? Next, greatest distance of a point. Greatest distance of a point means, let's say if P is a point which is lying outside the circle. Now the greatest distance of point P from the circle will be, PC plus R, PC plus R. Okay, and the least distance or shortest distance will be PC minus R. So see, greatest distance will be now PA will be the greatest distance and PB will be the smallest distance. So greatest distance is PC plus R and smallest distance is PC minus R. That's it. Power of a point. Friends, power of a point x1 comma y1 with respect to the circle is S11. That means substituting the given point on the circle. S11. That is what we say power of a point. Next, just remember this condition of tangency. So a line y is equals to mx plus c is said to be the tangent to the circle x square plus y square is equals to r square only if c is equals to r into under root 1 plus m square ma. If c is equals to under root r into under root 1 plus m square, then this line becomes the tangent to the given circle and this is called as condition for tangency. Next, point form of tangent. For a circle at a point x1 comma y1, for a circle S1 is equal, for a circle S is equals to 0, the equation of tangent at point x1 comma y1 is S1 is equals to 0. So what is S1? Xx1 plus yy1 minus r square equals to 0 for the circle x square plus y square is equals to r square. General method to write tangent for any curve. For any curve, friends, for any curve S is equals to 0, S1 is equals to 0 represents equation of tangent at a point P of x1 comma y1. At P of x1 comma y1, S1 is equals to 0 represents the equation of tangent. Next, equation of tangent, that is what we say, also known as S1 is equals to 0, or we also call it as capital T is equals to 0. So for a circle x square plus y square plus 2gx plus 2fy plus c is equals to 0, the equation of tangent at a point x1 comma y1 is S1 is equals to 0. That is, what is S1? Xx1 plus yy1 plus g of x plus x1 f of y plus y1 plus c is equals to 0. Parametric form of tangent. That means in place of x1 comma y1 we have r cos theta comma r sin theta. So x into x1, so xr cos theta, x into r cos theta plus y into r sin theta minus r square is equals to 0. So in that case what do we get? If you take r common, then x cos theta plus y sin theta minus r is equals to 0 is the equation of parametric form of tangent. So with that we are done with the circles. Then we'll go with parabola now. So parabola, ellipse, hyperbola, these three are conic sections. Even circle is also a part of it, but we'll discuss circle separately. Now parabola, all the terminologies of parabola will also be for ellipse and hyperbola also. Now general definition of conic is defined as the locus of a point which is moving in the plane such that the ratio of its distances from a fixed point to a fixed line is always a constant. That is, if PS by PM is equals to constant, then the locus of P is a conic. This fixed point is called as focus and fixed line is called as directrix. Fixed point is focus, fixed line is called as directrix. So the locus of a point P which is moving in the plane such that the ratio of its distances from fixed point to fixed line, that is PS by PM, is always constant, then locus of P is a conic section. Now this constant is called as eccentricity, friends. This constant is called as eccentricity. So based on the constant value, based on this eccentricity, the locus of P might be a parabola, an ellipse or a hyperbola. So if E is 1, eccentricity is 1, then it is a parabola. If E less than 1, ellipse. If E greater than 1, hyperbola. If E is equals to root 2, then it is rectangular hyperbola. Now, so the fixed point is called focus, fixed straight line is directrix, constant ratio is called eccentricity denoted by E. The line passing through the focus and perpendicular to the, see friends, the line passing through focus and perpendicular to the directrix, this line is called as axis of the conic section. Next, the point of intersection of conic and its axis is called as vertex. This point, suppose a conic is passing like this, then the point of intersection of conic and axis is called as vertex. Generally we denote vertex with capital A. Now general equation of every conic. Suppose if you take focus as alpha comma beta and directrix as Lx plus My plus n is equals to 0, then as you know friends, PS by PM is equals to E. So PS is equals to E square into PM square. Now PS is nothing but x minus alpha whole square plus y minus beta whole square, and E square into PM square is perpendicular distance from point some x comma y to Lx plus My plus n. Now this equation will be reduced to second degree general equation. Okay, this equation will be reduced to second degree general equation, and as usual I said this represents conic section only when delta not equals to 0. If delta equals to 0, then it represents pair of straight lines. So when focus lies on the directrix, and most important friends, when focus lies on directrix, though PS by PM is equals to some constant, if this focus, that is S, lies on directrix, then in that case for the curve, for second degree equation, delta will be equals to 0. Locus of P will always be pair of straight lines, not conic section. See, just now we have defined locus of conic section, that is locus of a point which is moving in the plane such that PS by PM is equals to constant, then locus of P is conic section. Though PS by PM is equals to constant, if S lies on directrix, then in that case locus of P is not conic section. Clear? Locus of P will be pair of straight lines. So we will define it as a conic only when S is not lying on the directrix. Now, when the focus does not lie on directrix, for parabola eccentricity 1, delta non-zero and h square equals to AB. For ellipse, E should be less than 1. For hyperbola, E greater than 1. Rectangular hyperbola, E will be root 2. For all of them, delta should be non-zero. Now, for a parabola, h square equals to AB, ellipse h square less than AB, hyperbola h square greater than AB. And for rectangular hyperbola, there is one more condition, that is coefficient of x square plus coefficient of y square will always be equals to 0. Clear? Coefficient of x square plus coefficient of y square will always be equals to 0. Next, if h is equals to 0, then a should not be equals to b, then only it will be a hyperbola. Then only it will be an ellipse. If h is 0, if h equals to 0, in this case if h is 0, then a should not be equals to b. If a equals to b, then it becomes circle. Okay. So to become an ellipse, h should be 0 and a should not be equals to b. For circle, as usual, we know eccentricity is 0, delta non-zero, h 0, a equals to b. Standard equation of the parabola. So we have 4 standard forms of parabola, friends. Y square is equals to 4ax. Y square is equals to 4ax is the parabola which has axis as x-axis and opening towards positive x-axis. This is how y square is equals to 4ax. The parabola y square is equals to 4ax looks like x-axis, y-axis, origin, and this is vertex. Vertex will be at origin. Focus S of a comma 0. Equation of directrix. Foot of the directrix is minus a comma 0. So equation of directrix is either x plus a is equals to 0 or x equals to minus a. Next, different terminologies of parabola we see. These terminologies of parabola are not only for parabola, all of them. Now axis is nothing but line passing through focus and perpendicular to directrix. Next, vertex. Vertex means the point of intersection of axis and conic. Double ordinate. The chord which is perpendicular to the axis. Is called as double ordinate. And focal chord means the chord which passes through the focus. A chord which passes through the focus is called as focal chord. Now focal distance, or we say focal radii. The distance of any point P on the given conic from focus is called as focal distance or focal radii. Next, position of a point with respect to a parabola. Friends, same story again. S11 less than 0, point lies inside. S11 greater than 0, inside, outside, and S11 equals to 0 on the parabola. Next, different forms of the parabola with their corresponding parametric coordinates. So for y square equals to 4ax, it is 80 square comma 280. Y square equals to minus 4ax minus 80 square comma 280. If you know one form, just by using symmetry, we can get all the remaining. Next, area of the triangle whose vertices are x1, y1, x2, y2, x3, y3 and inscribed in a parabola. Y square is equals to 4ax. Inscribed in a parabola, y square is equals to 4ax. See friends, if there is a triangle inscribed in the parabola, let's say A of x1, y1, B of x2, y2 and C of x3, comma y3 are the 3 vertices of the triangle, then area of this particular triangle is 1 by 88 times mod of y1 minus y2 into y2 minus y3 into y3 minus y1. Next, equation of the chord joining 2 points P of t1 comma t2. Now Consider a parabola y square is equals to 4ax. There is a chord which is joining 2 points, say P of T1 comma Q of T2. P of T1 means parametric coordinates. A T1 square comma 2a T2, 2a T1, a T2 square comma 2a T2. So if you know 2 points, friends, then we can get the equation of line, and that line is y of T1 plus T2 by 2 is equals to Ex plus A times T1 into T2. This is the equation of the chord joining the 2 points P of T1 comma Q of T2. Now suppose if this is the focal chord, that means it is passing through the point, A comma 0. If it is passing through the point A comma 0, what happens, boss? Put y equals to 0 and x is equals to 0 is equals to A plus A times of T1 T2. So finally you get T1 into T2 is equals to minus 1 if it is a focal chord. So from here we get ends of focal chord. Ends of focal chord will be AT square comma 2AT 1 point. Another point will be T2 is minus 1 by T1, no? So A by T square comma minus 2A by T will be the ends of any focal chord. So if the chord joining the points T1 and T2 passes through the point C comma 0, C comma 0 means then put y equals to 0, x equals to C. T1 into T2 is equals to minus C by A. If it is focal chord, then T1 into T2 is equals to minus 1. If the chord subtends an angle 90 degree at the vertex, that means like this, 90 degree at the vertex. So if this is 90, then what happens? Then T1 into T2 is equals to minus 4 and chord will always pass through a fixed point 4a comma 0. Length of the focal chord as usual, friends. If AT square comma 2AT, AT square comma 2AT and A by T square comma 2A by T minus 2A by T are the ends of focal chord, then the length of the focal chord, that means distance between 2 points, is A of T plus 1 by T whole square. Length of the focal chord inclined with an angle alpha with axis of the parabola is 4a times cosecant square alpha, friends. This is very important. Length of the focal chord, let's say AB, this is inclined at an angle alpha with axis of the parabola is equals to, AB is equals to 4a times cosecant square alpha. We have got questions based on this in the year 2024. In the year 2024, we have got these questions from this concept. The length of the focal chord, which makes an angle alpha with the axis of parabola is 4a times cosecant square alpha. Next, we are done with the parabola, then we'll enter into ellipse. We'll start ellipse. Same, friends, general equation of ellipse. If this second degree equation will represent ellipse if delta non-zero, h square less than ab. If h equals to 0, in that case a should not be equals to b. So standard equation of the ellipse is x square by a square plus y square by b square is equals to 1. Okay. So if this a greater than b, then ellipse is horizontal ellipse. If a is less than b, it is vertical ellipse. And this ellipse will be intersecting x-axis at a point a comma 0 minus a comma 0, y-axis at a point 0 comma b and minus 0 comma minus b. Friends, if you see this, it is an equation which is having even powers in both x and y. So hence it is symmetric with respect to both the axes. That is why we say it has two foci and two directrix. So for the ellipse x square by a square plus y square by b square is equals to 1, that is horizontal ellipse. A should be greater than b. Foci is a comma 0 minus a comma 0. Center is 0 comma 0. Vertices are a comma 0 minus a comma 0. Next, ends of major axis will be same, a comma 0 minus a comma 0. This b dash will be minor axis now, 0 comma b, 0 comma minus b. length of major axis 2a, length of minor axis 2b, equation of directrices x equals to a by e and x is equals to minus a by e. Okay. Next, these two are the two standard forms of ellipse. If a greater than b, it is horizontal ellipse, a less than b, vertical ellipse. Generalized version. Generally, we say x square by a square plus y square by b square is equals to 1. No? So, for any ellipse, if I say x square by a square plus y square by b square equals to 1, x comma y is a point. X denotes the perpendicular distance from y axis. Okay, but here what is this axis? This is minor axis. This is x and this is y. So y denote the perpendicular distance from major axis. So if you know perpendicular distance from major axis divided by a square plus perpendicular distance from minor axis divided by b square is equals to 1. Generalized version of ellipse it is. Position of a point with respect to an ellipse. Same story. S11 less than 0, point lies inside. S11 greater than 0, point lies outside. And S11 is equals to 0, point lies on the circle. Next, focal radii or focal distance, friends. PS1, let P of h comma k be any point, then focal distance is a minus eh or a plus eh. A minus eh or a plus eh, and sum of the focal distances is always equals to length of major axis. PS1 plus PS2 is always equals to constant, and this constant is equals to length of major axis. So that is for an ellipse x square by a square plus y square by b square equals to 1. Focal length is a plus eh or a minus eh, and for this it is b plus ek or b minus ek. This is for vertical and horizontal. Alternate definition of ellipse. The locus of a point which is moving in the plane such that sum of its distances from two fixed points is always equals to constant. So if this constant is greater than the distance between two fixed points, then the locus of P is an ellipse. Okay. The point P which is moving in the plane such that sum of its distances from two fixed points is always equals to constant, and this constant length should always be greater than the distance between these two fixed points, then we say locus of P is an ellipse. If this lambda equals to S1 S2, it is a line segment joining S1 and S2. Lambda less than S1 S2, no such point will exist. Auxiliary circle or eccentric angle, parametric coordinates. Guys, so simple. Auxiliary circle. Consider an ellipse x square by a square plus y square by b square is equals to 1. Horizontal ellipse. X square by a square plus y square by b square is equals to 1. Horizontal ellipse. Okay. So, for this ellipse, that means it intersects x-axis at a point a comma 0 and minus a comma 0. If a circle is drawn by considering the major axis as the diameter, if a circle is drawn by considering major axis as the diameter, then such a circle is called as auxiliary circle, we say, friends. So equation of this circle is x square plus y square is equals to a square. Why? Because this major axis itself will be the diameter. Now, for this circle, if I draw parametric coordinates, let's say this is some angle theta. So this will be a cos theta comma a sin theta. Okay. Now if I draw a perpendicular from point P to this axis, let's say M, it intersects at Q. So for sure coordinates of x coordinates of Q will be a cos theta, and if you substitute a cos theta in this, then y we get b sin theta. So the parametric coordinates of an ellipse x square by a square plus y square by b square equals to 1 is a cos theta comma b sin theta, and this theta is called as eccentric angle. Eccentric angle. If parametric coordinates of an ellipse is a cos theta comma b sin theta, this theta is eccentric angle. And auxiliary circle means the circle which is described by taking major axis of the ellipse as diameter. Next, chord joining 2 points whose eccentric angles. So if P of alpha comma Q of beta, P of alpha means a cos alpha comma b sin alpha, Q of beta means a cos beta comma b sin beta are any 2 points. Then the equation of the chord is x by a plus y by x by a into cos alpha plus beta by 2, y by b into sin of alpha plus beta by 2 is equals to cos of alpha minus beta by 2. Friends, now if this chord passes through a point d comma 0, then tan alpha by 2 into tan beta by 2 is d minus a by d plus a. If this is focal chord, that is d equals to a, then tan alpha by 2 into tan beta by 2 is e minus 1 by e plus 1. If d equals to minus a, another focus, then cot alpha by 2 into cot beta by 2 is e minus 1 by e plus 1. Very important points. Kindly make a note. With that, we are done with ellipse. Next, hyperbola, friends. So hyperbola, this represents the second degree equation, represents a hyperbola if delta non-zero and h square should be greater than ab. So standard equation of hyperbola is x square by a square minus y square by minus y square by b square equals to 1. If eccentricity is root 2, then in that case a will be equals to minus b. A will be equals to minus b, and that special hyperbola I call it as rectangular hyperbola. So tracing of hyperbola. Hyperbola is an unbounded curve. Ellipse is a closed curve. It is unbounded curve. It's an open curve, friends. Okay. So general terminology of hyperbola. Almost the terminology of ellipse and hyperbola will be almost same. Almost same. So focus, you'll be having focus here. Yes, focus. Same story. Focus will be a comma 0 minus a comma 0. Directrix is x plus a by e equals to 0, x minus a by e is equals to 0. Note, two hyperbolas are said to be similar if they have the same value of the eccentricity, and that eccentricity is equals to e is equals to under root 1 plus b square by a square. 1 plus b square by a square. Next, conjugate hyperbola. Conjugate hyperbola means the hyperbola whose transverse axis becomes its conjugate and the conjugate becomes transverse axis. Such hyperbola is called as conjugate hyperbola for the given. Now, for any hyperbola x square by a square minus y square by b square equals to 1, its conjugate is x square by a square minus y square by b square is equals to minus 1. This is conjugate hyperbola. And if EH denotes eccentricity of a hyperbola, ECH denotes the eccentricity of the conjugate hyperbola, then 1 by EH square plus 1 by ECH square will always be equals to 1, which is one important relation with respect to 2 in hyperbola, friends. The foci of a hyperbola and its conjugate are always concyclic and form the vertices of a square. A comma 0 minus A comma 0, 0 comma BE and 0 comma minus BE. Next, focal distance or focal radii. Same. P of h comma k, then focal distance from S1 is EH minus A or EH plus A. So there it is PS1 plus PS2 is equals to 2A. Here difference will always be equals to constant, and length of transverse axis it is. Mod of PS minus PS dash is always equals to length of transverse axis. In case of the center of hyperbola is not origin, then it is translated form, that is x minus h whole square by a square minus y minus k whole square by b square is equals to 1 is the translated form. Next, let P be any point on the hyperbola and L1 denotes the length of the perpendicular from P, then L2 denotes length of perpendicular. Generalized definition of hyperbola it is, because x square by a square minus y square by b square equals to 1. X denotes the perpendicular distance from y axis, and y denotes the perpendicular distance from x axis. So L2 square by a square minus L1 square by b square is equals to minus 1. That is what we say generalized version. Now position of a point with respect to hyperbola. Till now we have seen, friends, position of any point P of x1 comma y1 with respect to curve S equals to 0. S11 less than 0 inside. Parabola it is same, circle same, ellipse same. Okay, only for hyperbola it will be different, friends. Only for hyperbola it will be different. If S11 less than 0, point lies outside. S11 greater than 0, point lies inside. Okay, Because for a hyperbola, this region is outside region. This is outside region and this is inside region. Outside, inside. Next, correspond. A secant theta comma B tan theta are the parametric coordinates. X square by A square minus Y square by B square is equals to 1 represents the equation of hyperbola. Then A secant theta comma B tan theta are the parametric coordinates of any hyperbola. Next, so depending on this theta, friends, depending on this theta, we say whether the point lies in which quadrant it is. So if P theta belongs to 0 to pi by 2, then P lies on the upper branch. If P lies left or lower branch, then theta belongs to pi comma 3 pi by 2. Left upper branch, if 3 pi by 2 comma 2 pi, P lies on the lower right branch. So A secant theta comma B tan theta will be the parametric coordinates of the ellipse x square by A square minus Y square by B square is equals to 1. The last concept from hyperbola, that is chord joining 2 points. We have discussed the same equation of chord joining 2 points in parabola, ellipse and now in hyperbola. So chord joining 2 points eccentric angles alpha and beta is x by a times cos of alpha minus beta by 2 minus y by b sin of alpha minus beta by 2 is equals to cos alpha plus beta by 2. This point is important, friends. If the chord passes through the point d comma 0, then tan of alpha by 2 into tan beta by 2 is a minus d by a plus d. If it is focal chord, then tan alpha by 2 into tan beta by 2 is 1 minus a by 1 plus a. Or if it is another focal chord, that is minus AE, if D is equals to AE and D is equals to minus AE, then this will also be again focal chord. In that case, cot alpha by 2 into cot beta by 2 is 1 minus E by 1 plus E. So friends, with that, we are done with the complete theory part from the chapters of complete two-dimensional geometry, starting with straight lines, pair of straight lines, circles, parabola, ellipse and hyperbola. Okay, I request you to watch the session thoroughly and note down all the formulae, because we have many important formulae in this 2D geometry. Clear? So with that, we are done with this. See you in the next session. Till then, all the very best for your preparation. Have a great day.